Welcome to another great O'Reilly webcast. My name is Yasmina Greco. I am with O'Reilly Media, and I will be your host for today's event. Today, folks, we have Harry Percival with us, and he is going to talk to you about outside-in, test-driven development and unit test isolation with Python, Django, and Selenium. Harry spent an idyllic childhood playing with BASIC on French 8-bit computers like the Thomson T07, whose keys go boop when you press them. He spent a few years being deeply unhappy with economics and management consultancy. Soon he rediscovered his true geek nature and was lucky enough to fall in with a bunch of XP fanatics working on the pioneering but sadly defunct Resolver 1 spreadsheet. He now works at Python Anywhere and spreads the gospel of test-driven development worldwide at talks, workshops, and conferences with all the passion and enthusiasm of a recent convert. Folks, Harry is also the author of the brand new O'Reilly Media book, Test-Driven Development with Python, and we're very excited to have him with us today to present this webcast for you all. As we get the webcast started, I'd like to go over a little housekeeping to help you get the most out of today's event. First, you'll want to open your group chat widget if you haven't already done so. This is where we can interact with each other during the event and where you can submit your questions for Harry. We find that our audience usually has a lot of good knowledge to share, so we encourage you all to chat freely during the event. However, if you have questions for Harry, please preface them with a capital letter Q so we know that they're for him and we can make sure we see it for Q&A. You can also open, move, and resize any of the other widgets. If you would like to tweet from the Twitter widget today, you might need to give it permission to access your account. The Twitter widget will automatically append the event's hashtag to your tweet so you don't have to. And today, folks, our hashtag is Python TDD, all one word. If you should have any trouble with the webcast today, please take a look at your help widget. If you continue to have trouble, just post it in the group chat and one of our staff will help you right away. If you have choppy audio or stalled visuals, please try refreshing your window. And remember, the best thing you can do for a good audio stream is to close any apps that could interfere. People always ask, so I'd like you to know we are recording today's webcast and we will have the archive ready usually within 48 hours. And folks, at this time, it is my pleasure to turn the program over to Harry for his presentation. Hello, Harry.
Hi, Yasmina. Thank you very much. Thanks for a lovely introduction. And hi to everyone that's joined from around the world. I'm quite flattered and slightly overwhelmed. So yeah, thank you very much for coming. I hope you can all see the little screen share that I've started there. And that's basically my intro for today. My name is Harry. The website for the book, at which you can find the entire book, it's available for free and it's licensed under Creative Commons, so you can always go there and read that for free if you feel like it. Of course, my beloved publishers, O'Reilly, would be very pleased if you also choose to buy a copy, but that's up to you. So that's at obeythetestinggo.com. And my day job is at a company called Python Anywhere, which you should check out if you want a cool place to go and host Python web apps. Okay, so this talk is kind of an intermediate level talk, I guess. So I'm aiming it at people who know a bit of Django, know a bit of Python, and maybe have dabbled a little bit in testing, and have come across some of the sort of classic problems with testing and are looking to sort of take it to the next level. So if you're a total beginner, or if you've never used Django, or if you've never done any testing, you might find that some of this goes a little bit fast, in which case I apologize. And all I'd say is sort of hang on, see if you can sort of let it all wash over you. And then in your own time, you can go to www.obeythetestinggo.com and read everything that I've been talking about in your own time at leisure in sort of calm with a cup of tea and a biscuit and digest it properly. So that's where we are. So today what I'd like to talk about is I'd like to give a practical demonstration of what I call, or what's called outside-in TDD, outside-in test-driven development. And it's more or less the same thing as what's called double-loop TDD, double-loop test-driven development. As we go through that, I'd also like to start to have a little demonstration about halfway through of test isolation, so how to write isolated unit tests, why you might want to do that, and maybe cover this phrase, listen to your tests. So sometimes we have difficulties writing tests, and It's possible that if we take that as an opportunity to listen to our tests, it might be able to drive better design in our code, and I'd like to give you a practical example of that. And I'd also like to give you a practical example of where that can go wrong, and what the pitfalls of sort of perfectly isolated tests and mocking can take you. So hopefully we'll get to the end of that, and then we'll just have a little recap here of, what are all these different types of tests that we write, functional tests, unit tests, integration tests, what do they all do, and what do we really want from them? And that'll help you guys, I hope, to make your own decisions about what kind of testing would work best in your own circumstances, and how to evaluate them. Very good. In terms of questions, I'd like to stop sort of 2 or 3 times during the presentation to take any questions. So go ahead and post them in the little chat box there, and Yasmina will stop me every so often saying, Harry, it's been ages, let's stop and have a few questions and let everyone catch up. Okay, fine. So with that in mind, let's get started. So the situation we have is that we're halfway through a web development project, and what we've been building is a to-do lists application. And the reason it's a to-do list application is because I have no imagination, and that's the example that everyone uses, and I am no exception. So let me show you what this application looks like so you guys have a little bit of context. Okay. And we'll just open up a new browser window, navigate to it over here. Go local host 8000. So let me show you. Hooray, it's a to-do list application. On the front page, it says, hey, would you like to start a new to-do list? I go, I sure would. I'd start by start a webcast. Okay, so I can put an item into my to-do list. It arrives as item number 1. I can put a second item. Say hello to the webcast audience. And then I can go, all right, so go to sleep exhausted. That would be my 3rd item. So it's a fairly simple thing. I have a list. It has several items. And you can see there at the top of the screen maybe that we've got the URL list/2. So if I go back to the home page, I can start a brand new list. No difference. Okay, fine. And so that's list/3. So you can see here, I can have multiple different to-do lists. They're all stored separately, and I can go and find my old ones if I happen to remember the URL. So that's basically our situation. So this is kind of a real project. And what's happened is you can see over in the top that I'm logged in here. So I've made a login system for my website. And we're saying that the users of our website have come along and they've said, hey, we love this to-do list website. It's great to have to-do lists, but it's really annoying to have to remember the URLs for all your lists. So it would be nice if I could just come in and see all of my to-do lists in one place. If the website somehow remembered when I created a to-do list that it was my to-do list and it collected them all in one place. And so a My Lists page. So that's the new requirement, and that's the requirement that we're going to try and implement today using outside-in TDD and using test isolation. Okay, so it's a new requirement, and if you're anything like me, you're sort of thinking, oh, okay, well, I wonder how we could implement that. Let's take a look at the code. Back over on this guy. Okay. So let me show you the models layer for this application. Okay. We've basically just got 2 models. The first is the list model that represents a sort of parent object, which represents a collection of individual to-do items. And the second model is the item. So an item represents what the text of that to-do list item, and then it has a link to the parent list. So this is what, that's the base, that's all we've got in models.py, just those 2 items, list and item. So a to-do list is made up of many items, and they've got a foreign key relationship to each other. That's the basic setup. I'll just show you quickly around the views in the website. So there are just 3 views. One is the home page that says, okay, well, display the sort of home page to the user. And on that page, I'm going to show them a form to start a brand new to-do list. If they submit that form, that's get posted to this second view here called new list. So the new list view then receives a post request. It pops it into a form. It checks if it's valid. And if it is valid, it creates a new list object, and it calls save on the form. And what save does is it takes that list and it creates a new item for it. Once it's done that, it's going to redirect them back to a page that represents their list. If there's any errors, we go and show the errors. Okay. Final view is the view for viewing an existing list. And so this view's job is to take a list ID like this, to go and retrieve the appropriate list object from the database. and then to go and pass that through to the list template, and the list template is going to show all the items in that list. This view is also in charge of adding new items to an existing view. So if a request says, oh, come in and add a second item to a list, it uses this existing item form and will save that if necessary. So far so good. 1, 2, 3 little views. And so if you're anything like me, you're thinking, okay, well, we need to, we want to have users' lists all collected together in one place. So that means I need to associate particular lists with particular users. So what I need to do probably is go into my list models and start thinking, okay, well, if I had a foreign key relationship from my lists to my user model, then I could identify which lists are owned by which owner, and then maybe the view that does new lists can be in charge of assigning owners to lists that come in, and so on. And that's the sort of traditional way of doing software development. It's what you'd call inside out. And why is that? It's because we started with the lowest possible layer, with the lowest possible building block, which is the model here, and we're going to go and build the low building blocks first, and then we would go and build some new functionality in the middle layer, in the views layer, and then we would go and update maybe our presentation layer and create a template for displaying the My List page and whatnot. And the good thing about that is that, you've always got a solid foundation. You do your building blocks first, you build the things that use them, and then finally you build the things that use them. And what I'm going to contrast that with today is a different model called outside in. So might you be interested in outside in? Well, if you do this sort of inside out model, where you start with the low building blocks, I wonder if any of you have ever been in a situation where you started building some building blocks at the lower level, like maybe some model objects and some interfaces, and then you've gone, okay, so I'm building like this. I assume I'll probably want something that does this, and I would think I'll probably want something that does that, and oh, God, it'd be quite nice if it also did X and Y and Z, and it had a widget. And pretty soon you find yourself moving on to the next layer and going, oh, actually, now that I've got here, it turns out that the building blocks I thought I would need aren't exactly the ones that I want, and I'm going to have to go back and change them. Or, quite often, you've gone ahead and built a whole bunch of lower level functionality that you actually never end up using. So what we're going to contrast that with is doing it exactly the opposite way around. And we're going to build our application from the outside inwards. Okay, so the first step in sort of outside-in development is not to start with the outside layer. It's, of course, with all test-driven development, is to start with a test. And the kind of test that we use in double loop TDD, the very first kind of test, is what I call a functional test. Some people will refer to system tests or acceptance tests or end-to-end tests, but really it's going to be a test that tests the application from the point of view of the user. So I've got that pre-prepared over here, and I'm just going to go and create, do a little checkout for you guys. There we go. Okay, so here is our functional test. So what this test is going to do is it's going to go and pretend to be a user of the website, and in fact you can see that the functional test has these little human-readable comments that go through it. And the functional test maps to a user story. If you're doing some sort of agile development or requirements gathering, you might sort of write down these comments and give them as a sort of requirements document to your client or something like that. And so this is imagining what a new user can do with our website to do with this new functionality they want, the My List functionality. So Edith is logged in. This is just a little tool to have the web browser be ready and logged in when it comes to the website. So then I have a browser that goes in and opens up the URL on my computer. And then we're going to create a new to-do list. And so we're going to do that by adding a first item to the list and a second item. So I've got a list with 2 items. And then I'm going to make a note of the list URL. Okay. We then say that the user notices for the first time that they can actually click on a My Lists link, and she clicks through to that, and she can see that her email address is on this new page, and that she can see that she's got a link to her list there. So to try and make this all a little bit more concrete for you guys, what I thought I'd do is I thought I'd show you what I want the final product to look like. So I'm just going to pop in and start the server for a finished product, and I'm going to give you a little tour of the website as we want it to look at the end of today's session. Okay. Okay. There it is. All right. Okay. So here's our website that we're going to have right at the end, and you might notice that at the top here, I've got a new link that says My Lists. There we go. And on that page, I can actually see all the lists that I've already created. So I click on My Lists. I get taken to a new page on the website that says, oh, My Lists. And I can go and see my first list. Oh, that's interesting. And my second list. Oh, okay, fine. So that's what we want to get to at the end. Okay. Back to our code. Fine. So that is essentially the journey that my functional test is taking. Create a list. We click on My Lists. We see that that My List page has my email address in, so I know it's my page. I click on the name of the first list, and I click on the name of the second list. So one thing you may have noticed is, when we want to be able to go and find a list, I'm going to name it after the first item on the list. So if you have a list that goes buy milk and then go to shops and then whatnot, the list is called buy milk. So the user then goes and starts a second list, and then we can check that you can have not just one but two lists under My List and logs that. So that's our sort of functional test. Let's try running it. Okay, so this is my functional test actually opens up a real web browser. You can see the list being created there. It says reticulate slimes and immanentized eschaton. And then at this point, the functional test fails and explodes. I think you can see that on your screen now. And we get our first test failure, which you may be able to read here. And it says, okay, I'm unable to locate the element link text My Lists. So that's an expected failure. I've written a test for some functionality that didn't exist yet. And it's failing at the first hurdle, which is I haven't even got a link to go and view the My List page. And this is the point at which we start working outside in. Rather than jumping in and starting to think about the model there and whatnot, I'm just going to let this functional test drive the development, and I'm going to let it tell me what to do next, always being driven by what the user can do, what the visible functionality of the site is, and what the sort of UI layer demands. So the very first thing that I'm going to do is I'm going to go to maybe my base template. Okay, so this is my base template for the whole website. You'll see in a second it has a navigation bar, and I'm going to add a new link into the navigation bar like this. Now, what shall I have as its href? Well, how about nothing? There we go, My List. That's the minimal amount of code that I can change. I've added exactly one line of code to my whole code base. And I can leave that going, rerun my test, and see if it gets any further. Pop up, okay, it starts a list, starts a second one, it spots a new link, it clicks on it, and it gets through to a new page, and now it's saying, well, because my link doesn't actually go anywhere, it's not finding the username in there, but you'll notice that the functional test has moved on a little bit. So that's how we start with outside-in test-driven development. At this point, I'm sure that some of you have some questions, so is there anything at this point that I can explain or answer that will give you guys a little bit of context and help a few people not to be too lost?
Sure.
Yasmina, are there any questions at the top?
Yes, we do have one question in from Robert. Robert says, I noticed in your functional test that you use comments for the behavior. Any reason you don't start from the outside with a tool like Behave? Do you find that only useful when actually dealing with clients? Yeah, so I guess I don't know what Behave is, but if it's what I assume it is, which is a BDD tool or a behavior-driven development tool, then all I'd say is I don't have any experience of those. Not because I think they're a bad idea, just because in my jobs we've never used them. So I don't want to talk about them, but I have played around with them. They seem like very cool tools. So if you haven't tried out a BDD tool, by all means go and check it out and see if that could work for you. But if it was, that's absolutely the right place for using a BDD tool, and you can. What I'm doing there is just a slightly more lower level type of test. So good question. Thank you very much. Oh, the type of BDD tool that I've come across in the Python world is called Letters. So if anyone wants to Google that, that's Lettuce. Okay. Any other questions at this point? Yes, we just have another one here from Peter. Perhaps I need some remedial Selenium WebDriver education, but is it really this easy to write these tests from scratch?
I suppose it's like anything, it seems easy once you know how. I mean, let me show you. Let's go and have a look at the code there. In the test, in terms of the kinds of functionality we're using, Selenium is basically going to give you an API around making a web browser do things. And the web browsers are pretty simple. Like you can click on things, you can type into things, and you can navigate around a page, around the DOM, using things like tags, using things like IDs of HTML elements, CSS selectors, and whatnot. So I would say overall, Selenium is not too complicated. There are some subtleties, especially once you get into testing sort of more dynamic websites with JavaScript. You're going to have to tell Selenium to sort of click on things and then wait for other things to happen. And so there is a, that can be challenging. But at the basic level, no, Selenium is fairly simple, and I'd absolutely recommend it. Okay, fine. All right. Well, so let's carry on with what we've got going here. So our test is failing, saying, okay, I can't find edit@example.com because so far all you've built is a link that goes nowhere. Okay. So to move on to the next stage, I'm going to want to have, if I was working from this point onwards, I was probably going to think, okay, well, let's make this go to a new URL. So that's how you do that in Django. And it would probably be a URL called mylists. And I'm going to go to the URL that's mylists is going to be the one for a user with this particular email. So that would look like that. So notice what I'm doing here, which is that I'm driving the development from the outside here. I'm going, okay, well, what do I need to do in my template, in my presentation layer, to be able to get my functional test to pass? And what I need is I'm going to need a new URL, and I'm going to need a new URL that knows how to deal with a user, and I know that I'm going to need that to show the user's email. So I've got a few things I prepared earlier rather than typing everything manually. So just if you'll bear with me for a moment, I'll go and get those ready for you. Okay, so we want to go to fantastic. So you are on my list for the user.email. Okay, so at this stage, if I need to build a new URL, and I need to build a new template, and I need to build a thing that is capable of passing a user to that template, I'm going to move down to the next layer, which is rather than being in the presentation layer, I'm starting to get into, in an MVC framework, you'd call it the controller layer. Because we're in the world of Django, we in fact call it the views layer, or the views and URL layer. And that's going to, because I'm going to start writing actual Python code at this point, I'm going to be moving on from my functional test to writing what a lower level test, what we'll call a unit test. So let's go and have a look at my tests for the views layer that look like this. So I've got some tests for the home page, and tests for the new list view, and some tests for the list view, and I'm going to start a new class over here for the my lists. So here I'm going to use some of Django's testing tools, including the test client. And here again, I'm starting to think at the user visible layer. This is what I want my URLs to look like. I'm going to say, okay, well, it's inside lists, users, and I'm going to have the email address is going to be the sort of unique identifier for my users. And what this test needs to do is I'm going to go and fetch that URL, and I'm going to say, okay, well, if I want that URL to be rendering a new template, I'm going to have a new template called mylist.html. Fine. Let's go and tidy that up quick. Okay, so here we are. We'll get that URL. Let's try running that test. So we've got a different command for running the unit test compared to the functional test, and that is. And here we go. This is our first test failure. So here's our first test failure, which is in the test we just wrote, test my list URL renders the correct template, and it's going to say if I try and fetch that URL at the moment, nothing happens, no templates are used to respond. So that lets me go ahead and write some actual code. So let's create a new URL. And we're going to capture a parameter over here. And see how the test get on with that. Okay, everything explodes because that view doesn't exist yet. So I add a new view to my views file here. Rerun the tests. We're still getting to no templates were used to render a response. And at this point, I'm just going to go back to the one I prepared earlier for them. Okay. And the final failure is that it's telling me, oh, okay, my list.html doesn't exist. So we'll create that. Zip. And my test passed. Okay, so I've managed to wire together a new URL and a new view function and a new template. The template's currently empty, but I've got a lower level test that's been driven by the higher level test. And again, I'm working from the outside in. Let's take a look at what we've got outstanding so far. Okay, so whenever you get to a point like this in your coding where you've been through a little cycle of running the outside level tests, creating some unit tests, writing some new code, and you're not too sure what to do next, the great thing about double loop TDD is that you can always just go back and rerun your tests, and that should tell you, with a bit of luck, what you need to do next. So the tests still run, they can still create a list, they click on my list, yes, of course, my template is empty, so when the test tries to come to that page, it still can't find a header with the list email in. So let's go ahead and do a bit of work on our template. Okay, so here it is. And have a little look. Let's copy some boilerplate from the list.html. And so here we get into the next phase of outside-in development. We start a new template, and we're going to say the test is saying at the moment it can't find the user's email on the page. Well, let's go ahead and put that in here. Now, how could I put the user's email on the page? Well, what would be convenient is if this template actually had a variable called owner, and I could just render their email like that. So that would be perfect. Okay. So this is sometimes called programming by wishful thinking. Now, this template isn't yet being passed an owner, but it'd be nice if it would. And so outside-in development requires you to do this sort of programming by wishful thinking. It says, oh, okay, I don't have it yet, but it would be nice if the presentation layer was passed some variables like this. So I'm going to need the owner in the My List page. So that inspires me to write a new test. Let's copy this one. Okay, and so test it passes the owner to the template. Okay, so in this test, we're going to need an actual user. Okay, and finally, we need to import the user, and the new version of Django has a slightly magical way of doing this. And then we'll create a user and the other test just so that we can. So here's the second test. I create a user, I go and fetch my URL, and I say, okay, well, during the rendering of that template, I want to check that the owner has been passed in. Let's try running that test. Here owner. Okay. So let's go and make our view pass the owner to the template. Aha. Oops. Okay, and then similarly, let's import the user model like this. Fantastic. When the screen catches up with you there, you should see our new My List view, which, oops, I don't know how to find it. The new My List view, which will appear on your screen in just a moment, fetches the user by finding them by email, the email that's been passed in, and then renders that into the template as the variable name owner. So let's see if that gets my test to pass. It gets the unit test to pass. And now let's see if the functional test will pass. Okay, look at that. It's a bit ugly, but it's there. And what's the new test failure? It's now saying, unable to locate element, linked text is reticulate splines. So sometimes when you're looking at a big ugly traceback like this, it helps to scroll up and just double check, okay, which test is failing? Yep, sure enough, it's checking that. And then let's go and see what line it's failing at. So that's at line 44. So let's just go and inspect our test and see if we understand what's happening here. And that's at exactly this point. So the test is logged in, it's gone to the home page, it started a new list, it's found that the header is correctly saying the email address, but the list page currently doesn't have the user's lists on. So again, we've been working outside in. We started at the template, we drove a little bit more functionality in our view tests and in our views. So let's do the next little bit, a little bit more programming by wishful thinking. And we'll continue in our template to say, okay, well, let's say, okay, so if we were going to be able to display all the users' lists, we might be able to put them in an unordered list like this. And again, I'm going to program by wishful thinking and say, okay, well, I'm going to be able to iterate through the user's list. So I already have the owner in this template. So if I could get to their lists like this, I'm going to want to put a list item for each one of their lists, and I'm going to say, okay, well, that's going to be a hyperlink. And I'm going to be able to maybe get okay. So I'm going to have each of the users' lists by wishful thinking, and I'm going to say, okay, well, I also want to have the list needs to be clickable. Now, what kind of link text have I got there? I've said in my test that I want the link text to be the same as the text of the first item in the list. So I could do something a little bit like this. List.item set, and to get the first item, I can do 0, and then I could do .text. But that's hideously ugly. So again, I'm going to say, if I want my templates to be a little bit more readable, what if a list had a magical name attribute where I could just go list.name, just like that, and iterate through them. Fantastic. So this is my programming by wishful thinking now. I want to be able to iterate through all the lists. They're going to have URLs and names. Okay. Now, I can run that all I like, but at the moment, we can still create a list, we can click through to it, but because we don't yet have a relationship between lists and their owners, that's still never going to work. So this is the next stage at which now we need to start saying, okay, well, on the inside layer, how do I create a relationship between list owners and lists? And that's going to happen in a different view. I'm going to start thinking, okay, somewhere over here, whenever I create a new list, I probably want to do something like, if the owner is logged in, I'm going to want some code a little bit like this. So let's go ahead and write a new test for that. This is back in my tests for the new list view. Okay, and rather than typing out this entire view function for you, since it's several lines long, I'm going to go and fetch it from a commit I prepared earlier. So I'll just give you a moment. There. So on your screen in just a moment, you should see a new test that looks something like this. Test list owner is saved if user is authenticated. If I don't switch to the browser window. Here we go. Test list owner is saved if user is authenticated. So that's going to say we're going to create an HTTP request. We're going to assign the user to it. We're going to say that in the post of that HTTP request, which we're going to create a new list item. We pass that to our new list view. Then we retrieve a list from the database, and we assert that it should have had the owner assigned to it. So you may be wondering, why am I not using the Django test client for this test? Why am I using a sort of lower level type of test? And the answer is the Django test client makes it slightly harder to deal with logged in users, especially if you've got a custom authentication set up like mine. But the basic principle is the same. I'm calling the new list view. I'm passing it a request that has an authenticated user, and I'm checking that after that new list request has been processed, the list that's been created in the database actually has the owner assigned. So let's go ahead and run that test. And we get our first expected failure, which is list has no attribute owner. And if I go over into my views, I can implement it like this. So can anyone guess what will happen next? If I rerun that test, unfortunately it still doesn't pass. Because in order to get this test to pass, I actually need to go and allow lists to actually have owners. So I need to move down to the models layer and start defining that foreign key between lists and owners. So this would be normally the stage at which I would go down to the next layer, start writing tests for the models layer, and I can feed back through. But this is also a breaking point in today's talk. And from this point on, we're going to do some mocking and some test isolation. But it's also a good opportunity for you guys to ask a few questions. So is there anything outstanding in the questions list, anything that can help anybody that's slightly lost to get back on track?
Okay, we have many questions that have come in, so let's take a few of them here. Let's see, Adam would like to know, how often do you actually use the outside-in testing approach in the real world?
All the time.
Okay. Olga would like to know.
Sorry, let me expand on that. That's a bit of a ridiculous answer. Yeah, no, I mean, so absolutely. I work for a company that does extreme programming. That's quite religious about it. So all of the functionality that we have on our website, on pythonanywhere.com, everything there is written in an outside-in style. So we write a functional test first, a full functional test that exercises everything through the UI. Then we go in and we write unit tests, and then we go in and write the actual implementation. Now, you're presumably thinking, hang on, come on, that's impossible. What if you are just doing some exploratory stuff, or you're learning a new tool or whatever? There are exceptions. So when we have to integrate a brand new sort of third-party component, or we're using a brand new library, or we just want to try an experiment or a prototype, sometimes we do go ahead and do that without tests, just to do a bit of exploratory coding. We call that spiking, and it's one of the things that I talk about in the book in chapter 15 and 16, I think. So you should absolutely go ahead and try and knock together quick prototypes without any tests. But what we'll then do is we will throw away that prototype, go ahead and write the actual the functional tests, the outside level tests that we know, and now that we've actually built the prototype, we know what those tests should look like. We'll build those tests, and then we'll re-implement it using proper unit tests, and we'll often find that the second time round the code comes out a lot better. So yeah, no, I promise, we really do this stuff. Any other questions?
Yes, let's see here. Rick would like to know, are you familiar with the Mikado method, and how does TDD juxtapose with the Mikado method?
Okay, I don't know the Mikado method, so I'm sorry I can't answer that. I have to call that a major failing in my knowledge, I'm afraid.
Okay, how about one final one here for now?
Yeah, I would just say, tell me all about it. Send me an email. My email address is obeythetestinggoat@gmail.com. That sounds like an interesting thing. It's got a cool name. So send me an email and tell me about it. I'd love to learn.
Okay. And Scott would like to know, how is Selenium being logged into the site? It's responding to if user.email?
Okay. So Selenium is being logged into the site. Well, basically what I do is in that particular test, I've got a way of creating a sort of pre-authenticated session. I have a separate test that actually goes in and logs into the website using this tool, which is called Mozilla Persona. It's a sort of third-party authentication system. So in the book, this whole webcast is an extract from my book. These are chapters 18 and 19 in the book. And in the run-up to this, I've talked about basically how to set up a to-do list website, and also how to set up user authentication, and not just sort of boring username and password user authentication, but using a third-party component. So I have a test that actually uses the Persona login system and goes out to the internet and whatnot. Then the separate question, so that's how Selenium does it. Selenium does it, sort of for real. It kind of logs in, it has a cookie and whatnot. In the tests, which I think I can show you here. So in the Selenium test, it's sort of logged in for real. In the unit test, in this file in test views, I create a HTTP request manually, and I assign the user object manually. So I'm just creating the kind of request that this new list function expects to see when I'm exercising it. So the two different types of tests have slightly different approaches to how they prepare their environment to fixtures, if you like. And that's all discussed in a bit more detail in the book. Are there any questions out there that are about people who are just kind of confused about what's happening and where we're going and what the app is doing?
We've got a few folks asking if you could show how to do the perform a load test again, and then if they could see the low-level HTTP request again.
Okay, so let me see. I wonder where I put my... If I can remember that. Fresh. So if you're looking at the low-level test, that should be on the screen now. And so you can see that sort of creating an HTTP request, assigning the user to it, and it fills in the post dictionary, and it calls the actual new list function with that request, and then afterwards it's going to go and look in the actual database and see, oh, is there a list which has the appropriate owner? I'm not sure I understood the first half of that question. Could you read it out again, Yasmin?
The one dealing with the, let me take a peek here, the HTTP, where did it go, folks? See the low-level HTTP request again in the code window.
Yeah. Okay, so I think that's what I've just showed.
Okay.
Okay, fine. All right, so in the book, what I do next is I go ahead and say, oh, okay, well, I can't get this test to pass until I create some a foreign key between my models and my users. So I'd sort of go ahead over here, I go to test models, I would create a new test in here that says test list can have owners, I would go into models.py, and I would start creating my owner equals models.foreign key, blah, blah, blah. But actually, what that's doing is it's cutting a corner, because if I've got my view level test failing over here, I can never get this test to pass until I move on and make some model layer tests and some models changes. And there is actually a way of getting around this and getting all of our tests to pass at every single layer before we go to the layer before. We can continue doing programming by wishful thinking, and we can do tests that work by wishful thinking, where we can actually get this test to pass, even though the models layer isn't complete. And the way we do that, and people out there who have done a little bit of testing probably be knowing the answer already. The way we do that is with mocking. Now, mocking is a dreaded concept. Anyone that's played around with mocks for more than a little while soon grows to get quite suspicious of them. I'm going to sort of try and go through a practical example here of using mocks, show why people are suspicious of them, why tests that use mocks can be ugly, and then show the flip side of that, which is what I call listen to your tests. And the theory is that when you have tests that are sort of looking ugly or whose mocks are very complicated, often that can be a hint that your code is too complicated, and perhaps there's a way of changing your code that would improve the code and make the tests easier at the same time. So that's the theory I would like to explore now. So let's go ahead and try and build a mocky test for this level here. Okay. So how would that work? I've actually got one I prepared earlier. So I'm going to go and check that out for you now. It will appear on screen in just a moment. Okay, so a mocky test for this view would look like this. We're going to go and patch out the list class in the views.py. We're going to create a fake list object, which is this mock list. I'm going to make it into a real list, but I'm going to mock out its save function with a second mock. So I've mocked out the class. And I've mocked out the save function. So what I'm doing is I'm injecting into my view a fake list object. And then when I call my view, I'm going to check that the mock list, this sort of fake list, is actually had the owner assigned. So we can go and have a look at what that's like in the views file. Okay. So if we just remove the code that we had earlier, all right, we should be able to run this test. And we'll see it fail, which says that the list object has no attribute owner, but notice that this time it's the mock list object that has no attribute owner. And then I can enable the code, run the test, and see it pass. But there is a problem with this test, which is if I change these two calls around and I actually assign the owner after I save the list, well, the test will still pass. Because my test is mocky, it's no longer really testing the real world. It doesn't test what actually happens in the database. It's just testing what's happening to that particular mock object. So it's a very different type of test to the test I had before, which I was calling it a unit test, but if you're being strict about it, the test I had before that was actually looking at the database and using the Django test client, those sorts of things, are probably better called integrated test. And it's only now that I try and knock out the dependencies and make my test fully isolated from the database that I'm really writing a unit test. And you can see one of the pitfalls already, which is that I can write broken code that still passes the test. Now, I can actually adjust this test, and I can make, there is a way of checking that the order of the things were called with as well, and that looks something like this. Okay. Up. Okay. So instead of just having our mock list, what we're going to do is we're going to define a function called check the owner is assigned. That function is going to be in charge of checking that the mock list.owner has been assigned as the request.user, and then I'm going to set that function as a side effect onto the save function of the mock list object. Then I call new list, and then I'm going to check that the mock list save function has been called. So what that will do now is when my view gets in here and it calls save, when I call save over here, my magical mock function is going to run. It's going to realize the owner is not assigned, and it's going to fail in theory. Let's watch that happen. Sure enough, it does. And then if I move it up, I should be able to get the test to pass. But I have now got an extremely horrible test. Now, for somebody who doesn't really understand mocks, this test is almost totally unreadable. For someone who does understand mocks, this test is really ugly. I mean, it's got 1, 2, 3, 4, 5, 6, 7 lines of setup, 8, 9, 10 if you include the side effect function, and it's now really hard to look at this test and see what's happening. And this is a point at which some people would just go, well, you see, mocks are bad. And they're right. I mean, this is certainly a bad test. But mocks in and of themselves aren't bad. This just happens to be a bad use of them. And the alternative reaction, instead of just sort of throwing this out and saying, OK, forget mocking, is to say, OK, well, what if we listen to the tests? Maybe these tests are trying to tell us something. Maybe what they're trying to tell us is that the view that we're testing is too complicated. Like it has to deal with list objects, and then it also has to deal with saving them, and it also has to deal with this sort of form. I mean, if I have a look at this new list view, I sort of check whether the form is valid, and if it's valid, I create a list, and then I assign the owner. And actually, strictly speaking, later on, I'm going to have to put in an if here to say if the request.user is authenticated. So I'm going to be creating a form, I'm going to be checking if it's valid, I'm going to be creating list objects, I'm going to be checking if the users are authenticated. If they are, I'm going to do one thing and I'm going to save things. If they're not, then they're not. And then I'm going to save my form using a slightly different API rather than the sort of list ORM. I'm going to go to a different level and I'm going to pass that list in. And essentially, this view is too complicated. And it would be wonderful if it was just a lot simpler. What if I just had a view that instead of sort of doing all this stuff with lists and forms, only interacted with one object? What if I just had a form that could do all of these jobs all by itself, and it could look at the request user and decide whether or not to save it, and it would create the list and it would create the item for me? Well, if I had that, then I might be able to write a much simpler test. So I'm going to show you what, again, we're going to do programming by wishful thinking. Let me show you what a test would look like for a much simpler view. Okay, I hope you guys incidentally are enjoying my magical Vim color schemes which change every time you open it. So I'm going to take this old test, which is the way it used to be before I had all the mocks, and I'm going to leave it there as a sort of sanity check. I'm going to say, okay, well, let me try out this sort of isolation thing. And I'm going to, when I've finished, I'm going to be able to run this test. I'm going to take off this skip, and then I'll be able to see if it really works. And for now, I'm going to start experimenting with a simpler test for a view which is more like my ideal view. So again, I'm programming by wishful thinking. And the view is going to be called new list 2. So I'm actually going to build up a new view alongside the old view, which is going to look a lot simpler. I'm going to build the tests up one by one. So here I have just one mock because my view collaborates with a magical new form that doesn't even exist yet called new list form. set up with an HTTP request. I call the view, and I'm going to check the first job of this view is going to be, okay, does it pass the post data? Zoop. Fantastic. So we don't have a form yet. Import a new form in here. And I'm going to create a placeholder for it here. Okay, let's run the test. Okay. So my test is telling me I need to actually start using the new form. And we should be passing it in the post request. That's up to me. Fantastic. So let's move on and write a new test for the other things that this view should be able to do. And I'm just going to go and check out 3 or 4 little tests that should cover the whole of the functionality of this new view, and I'll show them to you in just a moment. Okay, so we'll have a test that the view passes the post data. We'll have a test that it should save the owner if the form is valid. We shall have a test that it doesn't save if the form's invalid. We should have a test that if the form's valid, it also redirects to the new list object that comes out of the form. And we should test that if it's invalid, it just renders the home page template to be able to show the error. Now, if you compare each of these tests to the sort of ugly mocky test I had earlier, they're much simpler. I have one mark here, and each one has a single assertion that's quite understandable. So okay, test it passes the post data, assert the form is called with the data. Test it saves. Okay, well, check the mock form that saves is called with the owner. Check that it doesn't save if it's invalid. And check that it redirects. Okay, we can mock the redirect. Check that it was called with the form saves object. And check that render is called with the home template in the barricade. Let's try running those tests. Okay, and we can now go ahead and follow these test failures and actually implement our new view one by one. So. Okay. And you can see the test drive this new, much simpler view. Now compare the old list view and the new list view, and you'll see that the old one is 1, 2, 3, 4, 5, 6, 7, 8, 9 lines long, whereas this one is just 1, 2, 3, 4, 5 lines long. It's very simple to see what it's doing. It takes a form object, checks if it's valid, it saves it in redirects, or it renders the home page template. And so what we've done there is by listening to a test that was really sort of painful to write, we've been able to write a simpler view, and we've been able to do all of this without even having a form object in forms.py. So we really are doing programming by wishful thinking. This form object doesn't exist at all, and at the views layer, I can get all my tests passing. So that's the first demonstration of isolated tests at the views layer. Are there any questions at this stage? Hi, Yasmin, are you there?
Sorry, I am here. We have lots of questions coming in here. Okay, Peter is asking, are 9 lines of setup bad for a test? I have tests that take pages of setup. Does your book offer refactoring tips for test code?
Okay. So, I mean, I'd say overall, yes. I mean, you know, it's hard to give a sort of perfect answer. Maybe you've just got a really complicated test and it needs a lot of setup. But I think in most cases, a test that has a lot of setup is an indication that maybe there's an opportunity there to try and simplify things. Is it possible that if you've got a test that takes a lot of setup, that means it's testing a function that's very complicated, that interacts with a lot of different objects? Is it possible that if you rewrote that function and split it out into several smaller functions, that you'd have simpler code that was easier to test and that was easier to understand? So that's answer number one. The second one is, particularly if you're writing tests for web applications or for data-driven applications that use a database, there are tools out there that simplify the creation of model objects, or database objects. So I'm thinking of one in particular called Factory Boy, which when I was showing my book to a couple of people early on, they said you absolutely have to recommend Factory Boy. The book itself doesn't use that as an example. The example in the book is too simple to really need that. But yeah, that would be my tip there, is Factory Boy. And the second part of it is there an opportunity to refactor your code to make it simpler? Now, maybe the answer to that is no. Maybe the answer is, look, this is one function. It's better to have it all as one thing that does everything together. And if I split it out into several different smaller functions, that would actually be worse. But in most cases, you'll find that splitting it down into smaller functions is an improvement. Anything else?
Thank you. Landon would like to know, I see in your examples you're using function-based views. What differences or advantages do you see in testing using function-based views compared to class-based views in Django?
Okay. So I explore a little bit about class-based views in the book. I've got a sort of appendix where I try and switch to them. I've got to say I'm very comfortable with function-based views. I haven't used class-based views very much. When I've tried testing them, it worked okay. It's harder to do things like sort of multi-test like this one. So overall, I don't use them much, and I'm not really experienced enough to give a very good answer to that question. If I was just to be facetious, I would say class-based views are horrible. I just use function-based views, and that's simple. But you know, that's just my ignorant opinion there. Anything else?
Yep. Earl would like to know: can you automatically drive and log results of Selenium testing for something like Jenkins or Hudson?
Absolutely. That is the topic of chapter 20 in the book, which I'm not sure if I've mentioned or if Yasmina has mentioned. But I've written a book all about testing, which is actually available. You can read that. So check it out at betatestingcode.com, chapter 20.
Yeah, and we're pushing that out to you folks in your group chat with a code to save you some money on it. So please do open that group chat if you didn't open it.
Oh my God, a discount! I mean, it is free. You can read it for free. But Yasmina and certainly the rest of ORI would be very pleased if you bought it, even with that massive discount code.
We want to thank everyone for spending their time with us today. A couple easy questions here that shouldn't take too long for you to respond to. William would like to know, which version of Python are you using, 2.7 or 3.4?
So this is Python 3.4. I've also, I started out writing the book in 2.7. Most of this stuff works. I've also tested against 3.3. I think that's using Python 3.4 because if you can, you should. Sometimes people can't. I don't know if this is the right place to get into a long debate about the relative merits of the two.
Super. All right. Back to you, Harry.
Okay. Well, so listen, folks, the webcast is advertised as lasting an hour. So I'm planning on going through the rest of this process, which is where we go down to the forms layer, we write some tests at that layer, and we find that mocky tests are ugly, and we have a second example of listening to the tests and driving some more isolation. We're going to build a sort of ORM helper method, and it's going to be an example of a pattern, I guess, where you try and remove ORM code or hide ORM code in your Django applications. We're going to get to the end, and then I'm also going to show one of the main pitfalls of isolated testing. So I'm going to show how by writing a lot of tests with a lot of mocks, it's possible to forget that things talk to each other and watch things explode. And I'll talk a little bit about identifying implicit contracts or programming by contract. And I'll talk also about the idea of why you might want to keep a few integrated tests around, even if you've got a suite of isolated tests. And the plan is to just close with a sort of discussion of the pros and cons of different types of tests and what we want for them anyway. However, I estimate that's going to take at least another half hour. So if some of you guys have a lot of other things to do, this is your opportunity to leave politely in a forgivable way. If you want to read all this stuff, it is available in the book online. And if you, Yasmin, are happy to hang on here, we'll sort of proceed at this point.
Let's keep going.
Okay. I hope you get paid either way. Okay. So what's the next stage? The next stage is to move down to the forms layer and say, okay, well, let's start building this magical form here. So I've got a class new list form, and I know that I want it to be able to sort of be initialized with sort of some post data, and I want it to be able to save lists. This is my new functionality. I want it to be able to save lists which have, sort of authenticated users and not authenticated users. Okay, so let's go and see what some tests for that might look like. Okay, so in my form, I'm just going to go and show you the kind of code that I think I might want. I'm going to have a sort of save method over here. And I'm basically going to be saying something a little bit like this. I'm going to create a list. I'm going to have an optional owner parameter on here. I'm going to say if the owner gets passed in, or maybe like probably more something like this. I'm going to assign the owner, then I'm going to save the list, and then I'm going to create an item. I'm going to say the parent of the item is going to be the list. I'm going to set the clean data based on the form data is going to be the item text, and I'm going to save it. So that's what my save method would probably end up looking like. Right? So how would I write some tests for this sort of a function? Well, they would probably look something like this. I'll just delete that and come back to it. So I know that my form save method is going to create lists and it's going to create items. So let's go and class new list form. And to make sure that I'm writing properly isolated tests, I'm not even going to use Django's test case. I'm going to use the unit test case. Okay. So I'm going to say test form save test form save is authenticated. Not authenticated. And to get that to work, I'm going to need to put a mock on the list class and the forms class, or something like this. yeah. That's better. So I'm going to write something like this, and then I'm probably going to have maybe something a little bit like passing the mock items in, and I'm going to start writing a test that looks a little bit like this. So I'm going to have the mocked out list item and the mock list class. I'm going to create a mock item, which is going to be the return value of the mock item class, and a mock list, which is the return value of the list class, and I create a mock user, and I'm going to say, okay, so this is going to be user.is authenticated and equals true. Okay, fine. So I'm going to create my form. I'm going to pass it in this little data here, which is a new item text. I'm going to call it is valid on it, right, fine. That populates the sort of clean data dictionary. And then, all right, I've got the same problem which I had in my view function earlier, which is that I need to make sure that a certain thing happens before I call the save function. So I'm going to check that the item text is assigned, that the items list is assigned to the mock list, and then we check that also the list has been saved before we try and save the item. And so then I'm going to put all of those checks as a side effect onto the save function of the mock item, and then I'm going to call save, and I'm going to get to this stage where I'm going to call assert true that the item is saved. So I check the item is saved, I check the list is saved, I check that the items text and its list are assigned correctly, and then I'm also going to say, all right, okay, fine. So maybe I'm going to have mark item dot owner should be the same as the request dot user as the user. And what I've done here is I've written another horrible mocky test. And I need to do this thing again where I go, hang on a minute, listen to your tests. My tests are telling me that this is a bit of a nightmare. Couldn't this be simpler somehow? What if, rather than having to use, instantiate lists and items separately, what if I had something simpler? What could be simpler than creating these lists and these items separately for this form class? Well, what if I had a helper function so that all this guy had to do, and def save, was just be able to go, let's see, list, create new, or even something else, create new. What if there was just a magic function called create new list that took first item text equals, I've got the post in the self.clean data. So again, programming by wishful thinking here. What if I just had a function that did this stuff for me? Well, that would be much easier, like a thing that was just in charge of doing the lists and the items and all that stuff, and all I tell it is, like, what is the first thing's item text and who is the owner? That would be great. So again, I do some programming by wishful thinking, and I can go and create a mocky test over here that rather than mocking all this stuff, and so rather than let's have it as a little helper method that lives on the list class. I could call it just a create new list. Could be a free function, or it'd be a little bit better to have it as a sort of helper function that lives on the list class. And I go list.create new. Okay. All right. So I'm going to start with is authenticated equals true. I'm going to call my own. And then all of this stuff is much, much simpler. If I call form.save, and I'm going to check the true. Okay, so we just need to import a form. I'm not going to use this form. And this is a much simpler test. I've got exactly one mock. I instantiate my form as new, and I've just got an assertion at the end, and just check that the create new is actually called with the right kind of parameters. Let's try running that and see if we get on a little bit better. Okay, so the first thing it tells me is, hang on, your forms module doesn't actually import the list. We'll do that. And then go and take away our sort of helpful code there. Run it again. Fine. Okay, now it's saying, hang on, your list.models.list does not have create new. Okay. Let's go to models. We'll create a placeholder for this amazing create new, but it doesn't actually need to do anything yet. What is it going to be? And then our next failure is saying, okay, well, we've tried to instantiate the new list form and pass it in this data with text as new item text, but it's saying object takes no parameters. And that's because our form isn't a form yet, it's just a normal Python object. So we can make it inherit from models.model. Not models.model, models.form. If only there was some kind of audio, then you guys could correct me whenever I do something stupid like that. Here, and back to forms.form, thank you very much. Okay. And then it's going to say, okay, well, we're not calling create new, fine. And run that. Okay. We're not passing in the owner. Equals owner. Okay, so I've got that test passing, and then the next thing I'm going to do, actually I've got a mistake here. Okay, my create new function should take the first item text. Zip. Okay, so now we're going to call list create new correctly. We pass in the first item text from our clean data. Does that work? Almost, not quite. Clean data isn't working because this form doesn't know about text yet, so I can make it inherit from my other form in here, which is an item form. Zip, and that passes. And similarly, I can write the test for the failing case, for the case where the user is not authenticated. Just copy this one. And in this case, I'm going to assert that we don't pass in an owner like this. Test that, fine, okay. And that leads me to write some code that looks a little bit like this. Is authenticated as a function, so we'll make it that. Okay, fantastic. So I now have two reasonably simple tests. They just create a user, one which is authenticated and one which is not. They instantiate the form in the same way in each case. And in the first one, we check that our magical new non-existent list create new function is called, in the first case with the owner, and in the second case without. And then our forms code is a lot simpler. Now, you could actually refactor this and write it in simpler ways if you like. But basically, if the user is authenticated, we call list create new with the owner. And if it's not, we call it without. And notice that at this stage, all my tests pass. And I still haven't actually implemented this magical save function or the foreign key relationship between forms, between users and lists. And you can actually drive the development of each layer. Like with your outside-in development, you can make sure that every single layer has got some requirements on the layer below, and you can make sure that every single one of the bits of code that you write is actually, ultimately, is driven by your functional tests and by your user functionality. So we finished the forms layer, that's all passing, and the final step is to move into the models layer. And let's see if I can just show you exactly what that looks like from one I made earlier. Okay, and that would be 1933. Okay. So here's our list model test. This is the old test, the absolute URL, and there are now going to be 3 new tests. I'm going to check that create new should create a list with a first item, so I call list.create new with a new item text. And that should create a new item and a new list. And I should have another second test to create new, which is called when we have the owner. Now, the first thing you'll notice about these tests is that they don't use any mocks. I think that's okay. At some point, you have to stop using mocks. And now we're down at the models layer. What I'm saying is, okay, well, at the models layer, since this code's entire job is to deal with the database, it's probably inappropriate to write code that's perfectly isolated from the database at this layer. So what we've said is we're going to have isolated tests for higher level code. But when we get down to the actual model layer, this is a stage at which you can say, okay, well, now let's use the real database because that's the most sane way of writing tests for this layer. And you can also tell that these tests are fairly simple. So we expect list.create new to create an item and a list. And then I've done these all in one go for you. But I've checked that, okay, list, can you instantiate that with an owner? And then can you instantiate it without an owner? So we can let those tests drive what we do. Fantastic. Okay. You'll forgive me if I forget the exact formulation you need. Okay. That explodes violently because we need a database migration. We get down to errors equals 4. We're saying create new has an unexpected keyword argument. Okay, so that means we can start implementing our create new function. Okay, so we've got list owner must be a user instance, and none has no attribute text. And now I need to take the owner. Okay, fantastic. So now all my model tests are failing, and I have these 2 remaining failures over here, which are happening in my view test. Now these, if you'll notice, these are actually part of the integrated tests rather than the isolated test that I made earlier. So you remember how I left the old test lying around, and they're now exploding, and they're exploding with the following error message. They're saying, cannot assign Django.contrib.auth.models.anonymous user objects. The list owner must be a user instance. So when you get an ugly traceback like this, you're going to go back up it. You're going to go try and find exactly where that's happening. It's happening somehow in line 36 in test view. So let's go and have a look at that. 36. Okay, so that's trying to save a post request in the new list view. Okay, well let's go and have a look at that. So this is in my old version of the view, and what's happening is it's getting to this stage, and we're actually saying, oh, we're saving the owner in all the cases because we're still actually using the old new list function. So I'm going to put a little guard here and say we only assign the user if they're authenticated. Try that again. So user is authenticated, and that passes. Okay. And so now we have the moment of truth. Now I've actually still got my old new list view, which is tested with the old tests, and I've got my new list view, which is tested with the new tests. Now all of those tests are passing. I've got passing tests for the views layer, I've got passing tests in the forms layer, I've got passing tests in the models layer. So everything works in theory. So let's find out if it works in practice. Okay. So we're going to go to list/URL, which at the moment is pointing at list.views.newList. And I'm going to change that to point to my new list on my amazing new list view and see what happens. Let's find out. I get a huge explosion. And this is, I guess, the third thing that I wanted to cover with you guys. So we've had the sort of practicalities of outside in TDD, and we've had some of the practicalities of mocking and how you should listen to your tests. And this is the third thing I wanted to talk about, which is some of the pitfalls of mocking. So it looks like our new list view doesn't work. Even though we've written a whole lot of tests for it, something has gone wrong. So let's go and see if we can figure out what it is. It's saying argument of type none type is not iterable. That's coming from this line here where it says return redirect list. And that's happening at line 30 in our new list 2 view. Okay. So let's go and have a look at line 30. That's happening here. We saw where we're trying to redirect a list. And it's because we're getting, where does list come from? It comes from the form.save. Okay. And so form.save is somehow returning none. What's going on there? Well, I can go and have a look at my forms. Here's my form.save. Actually, this form doesn't return anything. And so what I've forgotten is, although I've got, this form save is doing the right thing, it's creating a sort of new list object and everything. I've forgotten that it needs to return something back to the list view for it to actually work. And I'd forgotten that because it was just an oversight. And this is the kind of thing that can happen if you're writing isolated tests. What it means is when you're writing fully isolated tests, you have to be very aware of what we call implicit contracts. So what's an implicit contract? Well, that happens over here in my test for the views. When I wrote this test over here, which said test, the view redirects to the form returned object if the form is valid. And I started playing around with the mock forms save.return value. What that was doing in that test is I was actually having an implicit contract with my form. I was saying, right, when I'm writing this test, I'm assuming that this form's save method will return something. If you're going to write isolated tests that work, you need to think about not just the immediate functionality that you need from your objects, but what are the implicit contracts between them. The theory is that as you're writing these tests, every time you do something with a mock, like saying, so form.isValid.return value should be true. Okay, well, so I know there's a contract there which says that the form should be valid under X and Y and Z circumstances. And you might write these down on a piece of paper as you're writing your test. You're saying, okay, fine. So I need a form that has the same way of saying whether it's valid or not. And over here, I've got a form whose save method needs to return a value. So that's 2 requirements on my form. And what you might actually have done as you're writing this test in test views is go over into test forms and actually create a placeholder test in there, saying something like def test form save returns list object. So you can either do that, or maybe you might want to write them down on a piece of paper. And then you need to take a much more rigorous and much more methodical approach as you're writing your tests. And so this starts to get quite onerous. I mean, what it means is that it's asking you to be smart. And what we were hoping is that test-driven development would save us from being smart, and it would just help us to be able to do programming and not have to be smart all the time. So if you want to do fully isolated testing, you have two choices. Either you go through and you have to be very careful about identifying implicit contract and thinking about the dependencies or the way that your code interacts with itself. In the world of Java, you might have an interface, and that interface and the compiler would actually prevent you from making this sort of error. But because we work in dynamic language, we actually have to do this stuff manually. The alternative is that you're going to want to keep a few integrated tests around. So you can write several isolated tests that help you nail down the bulk of the logic inside your classes. And then you might have one or two integrated tests that actually check that everything bolts together, that really do use the database. So that's basically the lesson I wanted to show at that point, which was to talk about the perils of mocking, which is that unless you're being very careful about identifying implicit contracts between your layers, you might fail to produce code that actually is all glued together very well. And the possible remedies for that are either to be very careful or to always keep a few integrated tests lying around as well. So I'm sure you guys want to see the application actually working. So let me just do that for you. Okay, so our form ends up looking like this. It ends up doing the return, then that's fine. Our view, we now get rid of our old view and we just have the new view working just happily. And then in our tests, what I've decided to do is I'm going to keep all of my old tests are here, so the unit tests, which check that the post data comes to the new list form, that we check whether what happens when the form is valid, when it's invalid, that we redirect, or that we render the home page. And I've also kept, as a sort of sanity check, 2 or 3 of my original integrated tests that actually check that if you do a post request, it gets saved, that invalid input shows some errors, and that the list owner is saved in the third case. So that's the sort of full gamut of possible tests you might have for a view like this. Now, this is a very simple application, and I've shown an extremely rigorous way of testing. I'm trying to show this as a sort of example. In real life, you might be able to get away with writing a lot fewer tests for this sort of code. But what have we? What was the point in doing all of these isolated tests? Well, the point was, look at the difference between this view function that we've ended up with as a result of doing our isolated tests, and the old version of it, which I can show you over here. Chapter. So if you can actually read those, have a look at how much simpler the new code is than the old code. Now, this is a very simple application. I can convince myself that, you know what, I would have looked at my old code and decided to refactor it anyway. So maybe I didn't need all those isolated tests. Maybe. And I think that's the lesson there, is saying, well, if you do write isolated tests, they can be a guide to telling you when your code is too complicated, and they can give you just that amount of what we call, so what I've heard people call design pressure, that's going to force you to do that refactoring, or else you're going to have to live with very ugly tests. That's the end of the demonstration. I thought I might show you, you probably want to see at least that the application does the test actually pass. Let's see if it does. It'll be pretty embarrassing if it doesn't at this point. Here we go. We can take lines. Hop, 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 hop. Yeah, okay. I promise that does work. We'll just look at it in real life. Let's have a little tour around our website. should work. So, sign in. Here I am. There's my first list. If I go and create a second list, here's the home page. I'll click on the My List page, and sure enough, I've got both of my lists. They really do work. If I click on this list called Say Thanks to Everyone for Listening, it's there. So that's the working functionality behind the app. I'd like to give you guys an opportunity to ask any questions before I have a sort of final wrap-up and recap on what we've done.
Excellent presentation today, Harry. Thank you so much. We do have many questions in, so we'll just take them in the order we have them. All right. Mo Kento would like to know, how is writing these kinds of tests any different or better than manual testing? In the example you provide, it would be just as easy to manually test every part of a small to-do app. So when would it be suitable to write automated tests over manual tests?
Yeah. I think you've answered your own question there, really. So as soon as manual testing gets to be too much of a pain. So it depends. Like even for a simple to-do list app like this that I've showed you, that to-do list app, if I was to test that fully, I would need to be able to log into that app as an unauthenticated user. So make sure that I was in a private browser session. I would need to go and log into it, and I need to be able to create a list with multiple items, create a list with a single item. I need to be able to check that the URLs for all the different lists will work. I'd also need to check input validation, because I've built that code. So I'd have to check that if you enter an empty list item, it rejects it, or if you enter a duplicate list item, it rejects it. And I'd have to check a little bit of JavaScript that I've built in that app, which sort of clears any warnings or errors as soon as you start typing new stuff. I'd then have to log in and do all of the same things again as a logged in user. And then finally, I'd have to check this sort of My List page and make sure that it worked. So that doesn't take very long. I think it would take less than 5 minutes. So just imagine having to do that 3 or 4 times a day, 5 minutes of work. Well, that's not too bad. Okay, so how soon before 5 minutes? So how soon do you start to say, okay, well, is that worthwhile? What if it takes 10 minutes? What if it takes 20 minutes? What if your website has half an hour's worth of testing? What if it takes, well, as soon as your app gets beyond any sort of reasonable level of complexity, you're going to find that a series of automated tests are going to be more than worth it.
Thank you. Roderick would like to know, what version of Django are you using? I've tried 1.7 as used in your book, but I have a lot of trouble with migrations.
Mm-hmm. So the thing about migrations, I'm using Django 1.7. That's just a sort of futile attempt to make the book future-proof by picking the very latest technology we have. The new migrations framework at first kind of confused me. And I thought, oh, it's horrible. It makes you do migrations even for testing. I hate it. But I've sort of come around to it, and actually it makes a lot of sense. What people do find is if you start a project with Django 1.6 and you upgrade halfway through to Django 1.7, that won't break. It'll work fine in real life, but the behavior of the migrations is a little bit different from the way migrations behave if you've started with Django 1.7 all the way through. So if you're having specific problems with particular examples in the book, send me an email and I'll be able to debug those for you. I think overall, the way migrations work in the new Django is better than the old one. The sort of difference from a testing point of view is that your tests in Django 1.7 will not pass unless you have migrations to match the code you have in models.py, which is different from the old way. And I think that's an improvement. But I think it's probably a bit more of a detailed discussion that we can get into now. But yeah, by all means, if you're starting a particular bit in the book, send me an email and we'll fix it up.
Super. All right. Now, Peter would like to know, it seems like you could have made your original pass, or at least get further, by using static HTML rather than writing a Django template for loop. Wouldn't you want to get your original test to pass using fake code first?
Yeah, so the idea of using sort of fake code to get things to pass first, that's absolutely part of testing practice. And it's something you do for practice. It's something that you do sometimes to make sure that your tests really do have the coverage that you think they do. But it's also something that you don't have to do for every single bit of code. So look, I could have sat there absolutely and made static HTML pages for a couple of bits of it, but that would have been a waste of time. And so ultimately it's a judgment call. What I'm trying to demonstrate here is particular aspects of the isolation process. And for what I was doing today, I don't think there's any point in doing that. I think for your first couple of tests in a project, you absolutely should jump through all the hoops. But after a while, it's absolutely fine to skip ahead. I mean, the point of sort of really rigorous test-driven development is not so much that you have to do it that way all of the time. It's that you should practice it so that when you have a sort of really complex feature or part of your application, all of these techniques about going step by step, about doing fake implementations first, about doing red-green refactor, about going from working state to working state in the smallest possible steps, all of those techniques, when you practice them on a simple piece of code, then when you come to doing a really complex piece of code, they're sort of second nature. And when you really need them, they sort of become ingrained. In Python Anywhere, we did a big refactor of the payments application where we started making it accept credit card payments as well as PayPal. And I can tell you that all the time that we spent practicing the sort of smaller step-by-steps really came in useful when we had like the most critical part of our application, the bit that you really can't afford to get wrong. When you come to doing that, then you certainly are thankful for all the practice you've got in doing the sort of small steps.
Wonderful. A couple more questions here. This one from Jonathan. He says, our app has lots of animations. Selenium tests would pass, but if we ran them once, then would fail because an animation would take longer than expected or a DOM wasn't rendered. They become non-deterministic. Can you discuss some strategies?
Mm-hmm. Yeah, so this is a problem that you do encounter with sort of UI tests or browser-based tests, especially when you've got a rich GUI. And really you've got to build, you kind of have to roll your own sort of polling-based functions that are going to say, okay, well, I've clicked on a thing on the website, and now I expect a certain UI component to be animated in a particular way. I don't know, maybe you click on a button and a pop-up appears. So if you write some code that says, click on the button, now start using the pop-up, you're certainly vulnerable to the problem that, the pop-up hasn't appeared yet. So you're going to have these tests that sort of fail sometimes when it's appeared quickly enough and pass in other cases. And the technique there is just to build a little retry loop that says, okay, click on my button, and now I'm going to have a little function that goes, all right, check for the pop-up to appear, and if it hasn't, try again, and if it hasn't, try again, and give it a timeout that says, okay, I'm going to try again, every 200 milliseconds, I'm going to try for up to 3 seconds, let's say. And then your tests become about saying, okay, well, do all my animations complete within a certain time frame. And then, the tests become more sort of tied to performance, I guess. You sort of look at each of your UI components and say, okay, well, this pop-up should definitely appear within about one or 2 seconds. Oh, this thing over here uses a bit of a slow AJAX function. I'm going to give that a 20-second timeout. And this thing over here actually needs to go out to, I don't know, some third-party service, so I'm going to give that a sort of 2-minute timeout. And you build these sort of functions with different timeouts. And then if you find that some of them are particularly unreliable, you either need to think about tweaking your timeouts, or maybe there's some good reasons why those things are unreliable, and you need to look into making them more reliable. So it can be a warning that your app needs to be more reliable. I hope that answers the question.
Mm-hmm. And final question here from Albert. Can you say a few words about the difference between double loop TDD and other forms of TDD?
Mm-hmm. Okay. Yeah, good question, Albert. So I think the idea of double loop TDD is that we have these two different types of tests. We have the functional test that actually drives a real web browser and that's written from the point of view of the user that tests at the sort of user interface level that a user can actually use the new features on your website. And there, people talk about behavior-driven development. The sort of acceptance test or the functional test is the outside loop. So that's the test that you run, which says, right, let's try and build, use the whole application. Does it work? And that test sort of fails at some point, and that will tell you, okay, well, now I need to go into the sort of the inner loop, which is a loop of unit tests and code, where I'm going to write a unit test with a new piece of functionality that the outer test requires for it to get a little bit further along. And so what happens is, you run the outer level tests maybe a few times every hour, and you run the inner level tests several times, every couple of minutes, basically. So the unit tests get run very frequently, and the outer level tests get run sort of less often. And the sort of standard TDD has usually been about having a single loop. You would just write, you need a new piece of functionality, I would write one test for it. And so this idea of the two loops is about making a distinction between sort of functional tests and unit tests. And that's actually going to lead on quite well to the conclusion. So yeah, some people will say, do you need both kinds of tests? Maybe you can actually get away with just one. That's absolutely valid. It's up to you. What we tend to find in our application is that unless we have both types of tests, we're not absolutely sure that the application really works. And different types of tests have different objectives, which I'll talk about in a minute.
All right, that's all the final questions. Did you have anything you'd like to leave the audience with, Harry, before we close out?
Yeah, absolutely. So let's have a little look at this sort of slide here. So my conclusion is this. When you're looking at your tests, what do you actually want from them? So I've demonstrated some tests that can actually tell us whether an application is working or not. And I've also demonstrated that by going through sort of highly isolated tests, it is possible that your tests will also help to tell you when your code needs refactoring, and they'll hopefully drive you towards better design. That doesn't happen all the time, but it certainly happens a lot of the time. So we've got different objectives from our tests. We've got the objective that we want our test to tell us whether the application works or not. We want our test to tell us if we ever accidentally break anything. So not just so much that a particular feature that we were just working on does work, so my list page works, but also I want to be able to run all my old tests and be sure that I haven't broken anything. So that's the sort of correctness objective. Then I want something from my test, which is that I want them to help me write better code. So just the fact of having tests and knowing when I break things is going to encourage me to do more refactoring. So if I have a full suite of tests, I can refactor with confidence. I can go, well, I'm going to change everything from the lowest level, ha, 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 ha. And I can be quite happy that when I finish that refactoring, I can run all my tests and I know whether I broke anything accidentally. But also, this idea that some kind of test might actually help you to drive better design by sort of forcing you to think about your architecture from the outside in, to think about just even the idea of TDD without talking about isolation and all the stuff we did today, but even the idea of writing a test before you write a piece of code just forces you to think about what that piece of code should look like from the outside. And that hopefully drives better design. And then also we've got this idea that maybe fully isolated sort of pure unit tests might drive better design by forcing you to identify your dependencies. And the final thing is about workflow. Like, we also want this TDD thing to help us to develop quicker. So the person earlier on who was asking, are you really going to write tests for a really simple app like this? Well, not for a really simple app, maybe. But as soon as, an app gets to more or less the sort of level of complexity that I've got here, those tests are actually going to save me time. And what I want to be able to do is to develop as fast as possible. I want the time and effort I spend in writing tests, I want that to sort of be paid back in terms of speedier development. So the slower my tests are, the slower my development is. If I have to wait ages for all my tests to run, then I've got this sort of slower feedback cycle. I want to kind of know immediately when I accidentally break things. So those three ideas then kind of translate into ways you can evaluate your different types of test. And we saw three different types of tests today. We saw the functional test, which is a test that opens up a real web browser and clicks through the UI. And so that is the best guarantee that your website actually works, like a real web browser that talks to a real server. And here we talk to the dev server on my machine, but in the book I talk about how you can build those tests to actually talk to a real staging server, which might have a real database. Or if you've got a more complicated infrastructure, you might have like a cluster of several different types of server, a database server, a web front-end server, a back-end server, some kind of Celery server for asynchronous tasks. You can build real servers that emulate your production environment. You can run your tests against those. And those are give you confidence that you've really built a system that works, that you've configured all the servers correctly as well as writing all the correct code. But those kind of tests take time. If you have a test that actually needs to spin up a virtual machine on or several virtual machines, and then it needs to run a whole battery of tests that use a web browser, those are very slow. And to give you an idea, at PythonAnywhere.com, our test suite, our functional test suite, takes 14 hours to run. So obviously that's not something that we run every time we make a 3-line code change. right? The full test suite gets run by a sort of automated continuous integration system. I talk about that in chapter 20 in a book. I don't know if I mentioned I'm writing a book, which you guys should check out. So we're going to basically run those tests automatically, and they run overnight. And so the full run of suites run overnight, and then we come in the next morning and we go, oh, okay, did we actually break anything major? But we can run individual parts of that. Then we saw some integrated tests. So when we've got those tests that use the Django client, the self-dot client, tests that actually use the database, they're quite easy to write. They're easy to understand. And they'll tell you whether your application is really all stuck together. So does the database talk to the forms, talk to the views correctly? On the other hand, they can be a bit slow. So if you talk to people like Gary Bernhardt, who's a bit of a legend, he'll say, look, I can't be doing with any tests that take more than 300 milliseconds to run because I need to be able to run the test suite for my apps, just like several times a minute. And so then you get down to sort of lower level tests, isolated tests. These can be the fastest tests. And they're also the hardest to write, and they can be harder to read. But as we saw today, they can be a good guide towards better design. So those are the three different types of tests, and I think sort of a mixture of those three types, each one of which has sort of different objectives and different trade-offs, is probably where you want to be. And that mixture is going to be different for different people. Like Python Anywhere is an application that's like a hosting platform, and like all of our tests involve starting processes and shelling out to MySQL and like all these complicated boundaries between loads of different systems. So we need a lot of integration testing, a lot of functional testing. If you're making a really simple data-driven application that's just an API that doesn't even have a UI, maybe you can get away with only writing isolated tests or having a majority of isolated tests. So different things work for different people. But I think by thinking of those pros and cons and what you really want from your tests, you might be able to find the right mix for you. Yeah. Okay. Well, thanks very much, guys. That was almost 2 hours instead of the advertised 1 hour. Thanks for bearing with me. Thanks for being patient while I was doing the live coding. I know that can be a nightmare. I know it's probably a little confusing as well because the screen only updates, sort of 4 seconds after I finish typing and talking about something. So to every single person that's actually stood in the chat room, I am touched and honored, and it was a privilege to have you there, and I am grateful. And if you have any more questions, please get in touch with me, obeythetestinggoat@gmail.com. And if I didn't mention it already, I have written a book about all this stuff. You can check it out. It's at www.obeythetestinggoat.com. Thank you very much, Yasmina. Thanks, everyone involved.
Thank you so much, Harry. This was truly an outstanding webcast today, and we really appreciate you giving us all your time and expertise. Thank you so much.
Okay, bye, everyone.
Everyone that attended the webcast, thank you for attending and for staying with us here. And thank you for all your questions that came in today, because having your questions really adds so much to our event, so thanks for that. Also, just as we close out, so you all know, in your group chat are a couple of codes to save you some money today as a thank you for attending. Of course, one is for Harry's book. You want to save money on that because you will find so much great information in there that can really help you with your day-to-day, so take advantage of that code. Test-driven web development with Python. Also, Harry is going to be speaking at our OSCON conference. So OSCON is our flagship conference for O'Reilly, and it's going to be in Portland, Oregon, July 20th through the 24th, and Harry's going to be there live. So if those of you are in the area or close by, please come join us there, meet Harry, shake his hand, and we can save you 20% on your conference registration. The code is webcast. So write that down, webcast. Save 20% on your OSCON registration. Again, thank you, Harry. Thank you, everyone. This will conclude today's event. Goodbye, everyone.
Bye.